Today, we're going to learn about radian and degree measure, lesson 4.1 in your Larson Pre-Calculus book. An angle is determined by rotating a ray about its endpoint. The starting position of the ray is the initial side of the angle, and the position after rotation is the terminal side. The endpoint of the ray is the vertex of the angle. This perception of an angle fits a coordinate system in which the origin is the vertex and the initial side coincides with the positive x-axis. Such an angle is in standard position, as you can see in this image. Positive angles are generated by counterclockwise rotations, and negative angles by clockwise rotations. Angles are labeled with Greek letters alpha, beta, delta, and theta, as well as uppercase letters A, B, and C. Here you can see how angles alpha and beta have the same initial and terminal sides. Such angles are coterminal angles. Now we're going to learn about radian measure. The measure of an angle is determined by the amount of rotation from the initial side of the terminal side. One way to measure angles is in radians. This type of measure is especially used in calculus. To define a radian, you can use a central angle of a circle, one whose vertex is the center of the circle. 1 radian is the measure of a central angle that intercepts an arc S, equal in length to the radius r of the circle. Algebraically, this means that the measure of an angle theta equals to S over r, where theta is measured in radians. Because the circumference of a circle is 2 pi units, it follows that a central angle of 1 full revolution counterclockwise corresponds to an arc length of S equals 2 pi. Moreover, because 2 pi is approximately 6.28, there are such over 6 radius length in a full circle. Because the units of measure for S and R are the same, the ratio S over R has no units. It is simply a real number. Because the radian measure of an angle of 1 full revolution is 2 pi, you can obtain the following. Other common angles are shown in the figure below. Recall that our coordinate system has 4 quadrants: first, second, third, and fourth quadrants. In this figure you can see in which quadrants your angle may be located in. Complementary and supplementary angles. 2 positive angles are complementary complements of each other if their sum is pi over 2. 2 positive angles are supplementary supplements of each other if their sum is pi. You can see this in the figure below. Degree measure. A second way to measure angles is in terms of degrees. A measure of a degree is equivalent to a rotation of 1 over 360 of a complete revolution about the vertex. To convert degrees to radians, multiply degrees by pi over 180. To convert radians to degrees, multiply radians by 180 over pi. To apply this conversion rules, use the basic relationship pi equals to 180. Take note of these important formulas and key points you should know. The arc length S is equal to the radius times the measure of your angle theta. The linear speed is equal to the arc length divided by time, and your angular speed is equal to the central angle divided by time. The area of a sector of a circle is equal to 1/2 times radius squared times the measure of your angle theta measured in radians.